Let me see. Okay, I don't see any questions in the Slack. So I guess, yeah, we can bring back, I mean, we have all the presenters here. So if you have questions for anyone else in the session, feel free to ask. And thanks for the great talk and QA session, Mike.
Thank you.
Rohan has a question.
Yeah, all right.
Sorry, yeah. So I had a question for the first paper, Cuckoo Try. My question was like, how is the range query performance of the Cuckoo Try compared to tree-based indexes, given that you use a hash table at the end?
So what we did to support range queries is to also have a linked list of the leaves that is sorted in the order of the strings. And because it is a linked list, if you have a long range to extract, you have to traverse it one by one. So it is slower than other indexes. Yes, so that's currently somewhat slower.
I see. Okay. Thank you.
Related to that, you support integer keys, which maybe do not really, I mean, they don't directly correspond to like a trie data structure, right? So do you support those or not really?
So you can pad your integers to a fixed size and then store them big endian, and then they're sorted like strings. So we just transparently support them.
I see, that makes sense. Thanks.
Well, are there questions for anyone else? All right, so thanks again, everyone who presented. I think we're at the end of the time slot for the session, but I'm sure people can continue answering stuff in Slack. And I think the next session begins in 14 minutes. Well, actually, it's the poster session next, so I guess, yeah. Mm-hmm.
Yeah, I just wanted to say a note about that. We still have lots of content for the rest of the day. So we have poster session happening on GatherTown. We have Ask Me Anything sessions, and we have sponsor info sessions all happening later today. So after the break, please come back, and after the post session, we'll have all this content. Thank you.
Thank you very much. So unfortunately, it looks like the authors of the paper are having some technical difficulties joining. So what we're going to do to give them a chance to send themselves up, or hopefully they will, move the panel forward a little bit and bring back Jeffrey, Adam, and Adar for any opportunity to ask more questions if you have, or sort of to engage in discussion. So let me just bring them up. And feel free to ask questions in the Slack if you have any pending from last time. Okay, so I guess one question I was broadly interested in is, Adam, is there a way that you could see relaxing consistency in the way that Jeffrey did that would bring better performance? Is there a link between the two work where, you know, Jeffrey was seen in the context of distributed systems and you were very much in the context of sort of low-level hardware? Do you see this being possible?
Well, So our database doesn't support transactions. So the example that Jeffrey showed doesn't directly apply to our database. I do think it is possible to relax the consistency guarantees that we provide, and so reduce the number of locks that we require or something like that. So there's definitely a trade-off, but I don't know if we can do what Jeffrey did, where we keep all invariants, but still improve the performance.
Yeah, and another maybe possible direction would be to look at a distributed version of our index. And then maybe there is some potential there to have like a spectrum of consistency guarantees.
I guess, Jeffrey, to ask you the reverse question then, have you looked into your work to sort of optimize not just distributed systems, but also main memory, multi-core databases?
So I haven't given it much thought, I admit. I think one thing that seems to be key for relaxing consistency in this way is systems where you're maintaining multiple versions. So, right, like overwriting in place can potentially get tricky, because then it becomes hard. You know, at least as much as I've thought about it, it seems hard then to be able to like really serve old versions as we're trying to do, right? Like both simultaneously serve an old and a new version, as you were sort of seeing in the examples that I was showing in my presentation. So I think maybe what Adam was suggesting of like a distributed version of this cuckoo try could be interesting. Yeah.
So we already got December for OSDI 2022, so I guess SOSP 2023?
Yeah, exactly.
Great. We have a question from Jiang. If you want to introduce yourself and ask.
Hi, I'm Jian Yu from Hong Kong U, and I have a question for the RSS paper. I wonder what is the difference between the regular sequential serializability and the so-called strong partition serializability. Have you heard about the strong partition serializability before?
No, so yeah, I was just trying to recall. I don't think I'm familiar.
Okay,
with...
so it guarantees linearizabilities within partitions, and but only sequential consistency across the partitions. So
I see.
Yeah.
So without knowing the details totally of the definition, I think they sound somewhat similar. They definitely sound similar and like sort of within the same space. I think RSS would be stronger because it's providing some real-time guarantees. So for instance, it has the guarantee that when a write completes or a read-write transaction finishes, all future reads read-only transactions have to be returning at least a value at least as new as that write. There's also potentially a difference in the way we're defining causality that is as far as I know, isn't really captured by previous definitions of sequential consistency. So I think at a high level, that would be my guess about what the difference is. But I'd be curious if you could add that or like ping me with that paper. I would be very curious to read it.
Okay, and I don't think there's a paper that's like kinds of industrial definitions. Yeah, we can talk about that later.
Yeah, that'd be great. Cool. Thank you.
Cool.
looking for some more questions. My poor laptop is struggling with the amount of tab switching. I apologize. Yes. So we have a question by Hawei, and this is for the Kukutrai paper. You've only seen one or two other data structures indices that specifically exploit MLP. Why do you think this is the case? Is MLP not that big a factor in performance, or is it too difficult to fully exploit?
Well, I think it is mostly the second one. The difference in performance that, at least in certain cases, is pretty large. But it does apply only to very specific data structures. So what we did with the try to put it into a special kind of hash table, it is not a trivial transform. I cannot say how you do it generally for any kind of data structure. So for each, you have to tailor some specialized solution to exploit MLP. I think that's the main issue. And also for tries specifically, the approach of simply putting the try into a regular hash table requires a lot of memory. So I think that's why nobody did that. You do need the specialized hash table to support anything longer than a few byte keys. So I think it's generally the thing that you need a specialized technique for each data structure, and for tries you also have to solve the memory issue.
I think also maybe at a higher level, at least that was the case for me, it's an issue with computational models. So MLP is something that comes from the hardware, and standard computational models don't really consider it. So I think maybe it was just outside of the radar for a lot of designers. And I think one of our contributions is to show the potential that exists for looking at, relooking at designs and trying to explicitly identify what you can do with MLP.
So do you think there are other, without asking you to reveal too much about your future plans, of course, but do you think there are other areas or data structures in which there's an opportunity that you see?
So I don't know. I don't know if it is such a popular use case, but I think that linked lists can also be made to use MLP. I remember that I saw some work on it, and yeah, I think that linked lists is the only one that I remember seeing. So maybe there is a potential there.
Would your answer change if you had things like transactions or locking going on, where you actually had to sort of worry about concurrent accesses modifying the structure in some kind of atomic way?
Can you repeat the question?
I'm curious if you were to add transactions, for example, or having to worry about transactional isolation like databases do, in your, say, your Kukutrai, your sort of your DRAM indexing, whether if you had more complex locking needed, whether your answer would change.
Actually, I didn't think about it deeply, but I believe that our current locking does not support transactions, and you'll probably have to add another layer of locks somewhere. But currently, the main source of overhead isn't the locking and the concurrency support. We have in the paper benchmarks with and without locking, and the difference is not that large. So it will definitely hurt performance, but I think it won't be a major issue.
Great, thank you very much. Well, I think this brings us to 10:15. Unfortunately, it looks like the Caracal authors were unable to resolve their technical difficulties and so won't be able to join. So I would encourage you to ask all your questions online, ping them. They're going to be around for the rest of the conference. This also applies to any of the panelists currently present. I look forward to seeing the discussion continue in the virtual hallway tracks. So before I release everyone, thank you very much for all the panelists for either getting up very early or staying up very late. The poster session is going to be starting just after the break. So you should have seen a link to GatherTown, which is where we'll be hosting the poster session. The link up until now is password protected, but now it's going to be open. So it should open either now or in the next few minutes. And I would encourage you to continue the conversation there with the authors. So with that, thank you very much, everyone. And I look forward to all of these SOSP and OSDI submissions that are upcoming. So thank you. And
Thank you.